So here we've been given f of x is equal to g prime of x. So we've been given the graph of f of x. So this really is a derivative graph. Okay, so this is a graph of the derivative because we want to find some information about the graph of g. So we want to find the local min and max points of g. Well, we're going to find that where the slope is equal to 0. So that's when we need to see where the graph crosses the x-axis. Now, not only does it have to cross, we also have to think of the change of slope, okay, from positive to negative. So at -2, we have a 0 slope here, and we know that it's negative slope because the y values down here are negative. Okay, so the y values of this graph, okay, are negative. So I should actually write this as g. The y values of this slope are negative. So that means the slope is negative. We end up with a horizontal slope here because it's a 0 slope when it crosses the x-axis. This section is positive, so we know that if the y values of the slope graph are positive, that means we have positive slope. It goes up like this, and we can see that that coordinate is going to be our minimum point. So that's a local min. Okay. Now, if we're testing other points, we could test endpoints as well to determine whether it's a local min or max. So that's going to be a local max because it's going to start up here. And then because that is going up, that's also going to be a local max, but those are endpoints. So for part B, we're looking for the inflection points. Inflection points happen where the derivative graph changes direction. So at -3, we have a negative slope on one side. So negative slope of the slope means negative second derivative. That means we have a negative concavity here. Okay, that's an undefined. But on the other side of this, so this is pointing down, so the slope of the slope is negative. Here the slope of the slope is positive. That means that the second derivative is positive, which means we have a concave up situation. At 0, we have a similar thing happening. Again, that's a kink, so it's non-differentiable. But on this side of 0, we have the slope of the slope is negative. The slope of slope is the second derivative. It's negative, so that means we have a negative concavity. So on this side, the slope of the slope is positive. On the other side, the slope of the slope is negative. So then we have points of inflection at x equals -3 and 0. And we have to check for change of concavity for, say, we have inflection. Part C says, for what regions is a function g both concave up and increasing? So increasing means it's positive. Okay, so increasing means that we have to be on the positive side of the x-axis. That means it's a positive slope. That means it's increasing. If we want concave up, we need to have it sloping up. So it's going to be this section here. That's going to be the region that's both concave up, which is sloping up, or the slope of the slope is sloping up, and then it's increasing. So it means that the y values of the slope graph are positive. So in the region from -2 to to 0, it's both concave up. The g graph is both concave up and increasing.